Hello, we're going to have a look at star and mesh topologies in this video. And this is another category of network we've got to talk about. We've already looked at LANs and WANs, which categorize networks according to their size. And we'll also look at peer-to-peer and client-server in the next video. Topologies are all about categorizing networks based on their arrangement. And the word topology we can sub out for arrangement. How are the devices physically arranged in our network? And there are a number of different topologies. We're just going to have a look at two of them in this video, starting with the star topology, which is maybe the most common, especially in a home. So in the star topology, in this arrangement, each device in the network is connected to a central device. So this could be our network. We've got a router, say, as our central device, and every other device in our home, for example, is connected to that router, either by wires or wirelessly. And all messages that go to the other devices have to get sent through this central device, right? If I'm wanting to print something from my laptop, the print request goes via the router, then it goes to the printer. So it's all going directly through the central device. What exactly this device is can vary. It could be a switch instead of a router. It could also, if it's a wireless network, be a wireless access point, and it could also be a server. An alternative arrangement to the star topology is the mesh topology. In this approach, every device is connected to every other device. So it looks more like this if we were to draw it as a diagram. Now we typically think of these as being wires, which they are in most cases. It could be wireless, but typically this would be wired in a mesh topology. But every device has got a connection to every other device. So when a message needs to get sent, it will be sent down the direct path to the destination. If I want to print something from my phone, I send it directly to the printer. It's not going to go via any of my other devices because I've not got this centralized device like a star topology had. Now, a really important point to make here is these are only really suitable for very small networks. If I want to add another device into my network, I now need to integrate it and connect it to every other device already there. And we can see a massive jump up in the number of wires which are potentially needed. And if I want to add another device into my network, this adds even more connections to my network. So it very quickly becomes overly complicated. And this is why mesh is only ever used in very, very small scales. Now I've started doing that already a little bit, but it's really important to be able to evaluate these topologies. So the benefits of mesh, the key one is performance. Performance can be really high because you've got a direct path available. If you're able to spread out all the messages along these direct paths, there's less chance of things like collisions. And also you've got quite a lot of backups available in this network because you've got lots of alternative paths. If your direct path gets congested or the direct path goes down, you've got an alternative or got multiple alternative routes to get to the destination. Now there's only really one drawback, however it is a massive one, and so this is why mesh topologies just aren't used particularly often. It is very difficult and expensive to add new devices to the network. And this is because every time you add a new device, you need to connect it to all other devices. Now, if this was a wired network, you've got to add loads of physical wires. It gets really messy. It could be a trip hazard and it's expensive. If it was wireless, you've got lots of very similar signals which are potentially going to interfere and collide. And this is why star topologies are a lot more common, especially in a home. We can add new devices a lot more easily and a lot more cheaply. All we need to do is just connect our new device to the central device, either with a wire or wirelessly. We've also got a bit more control of our network via the central device. The central device is able to potentially monitor messages being sent. Because everything has to go through it, it has additional control. However, this central device is so important to the network functioning correctly, and it's a single point of failure. That means if it breaks, the whole network will go down because we are relying on the central device working to be able to send messages at all. Even in a less extreme situation when it's just being slow, the central device may hold up the flow of messages. It may cause congestion if it's not good enough, essentially. And this is why if you want to buy a high-performing central device, it can be very expensive to ensure that it's not holding up any of your messages. And lastly, if an attacker were to gain access to this central device, they are able to intercept all messages, which is clearly a nightmare for security. Now, despite me putting quite a few drawbacks there, We do use star topologies more than mesh topologies in reality. There are other topologies as well, and often we use a combination of a few. Please do learn these evaluation points for both star and mesh.